Hi everyone, here I am at Las Vegas at Consumer Electronics behind me. This is a little bit like, like my story and how was it in Vegas, Daniel. We spent 3-4 days which were amazing talking about technology, and I just want to give you a little bit of my story, and we will talk about what we did and about NXP and the things we presented and things we show. But first, before we go into that, let me just share a little bit of the feeling on how it feels to be in Las Vegas, in case you've never been there or you think like coming to get an idea of what it feels like. First of all, what they don't tell you is that in Las Vegas it also gets cold. So we had a pretty cold week this week. It is sunny, it is nice, but it is cold. So this is why I keep my hat on, in case my grandmother sees this, not to get me in trouble. I'm fully packed. I have behind me the convention center, the main convention center where this event takes place. It's a huge. It's the size of a neighborhood. I think somebody claims it's like the biggest one in the world. I don't know if it's the biggest one or not, but it's absolutely a huge place. All the companies, there are over 130,000 people coming here, all the companies and so on. I'll show you where NXP Booth is and where we build. NXP has actually built a booth. We'll go there. But yeah, this is the site, and it's not the only site. There is also the Venetians. Haven't seen much of it. Actually, I've been presenting all this time, so I didn't have a chance yet to see the event itself. We spend most of the time explaining our products. So I'll walk you a little bit. Let's go. There is a monorail. Maybe the best way to walk faster around in Las Vegas is with this monorail, which takes you to the strip. We'll go to the strip. I mean, you cannot make a video about Las Vegas and not show the strip. I'll show you the convention center at large. We'll walk a little bit, and let's take the monorail to go to our NXP booth, and yeah, we'll talk more there.
Monorail now arriving, northbound platform. On ldmonorail.com. And at the end of the day, the monorail is a great way to get to and from your dinners and after parties. Now arriving at Boingo Station at Las Vegas Convention Center.
All right, so here I am. The building behind me, it's NXP booth. It is a 2-story building, and it was put together for the event. It is impressive how it looks inside. It's really nice place. We spent 4 days here talking about software, talking about our technologies, our products. I'll walk you a bit through it. I won't be able to do justice and present everything. There is a very good walkthrough made by Lars. There are a lot of things that have been presented by our social media team. They've done a great work, and there are so many interviews and so many things out there on LinkedIn and on NXP.com. I've been here to talk about software, to talk about how you do software development in the cloud. We talked a lot about automotive, about how the architecture of the car looks like, how the software that we do, the tools. Tools is my main course, my main menu. My team is building the tools that NXP provides to support the enablement of these processors. So I'll walk you there. You can see this is how it looks around. It is a huge place. Again, this is not all of the place. It's just the area where it's kind of like a parking lot where they build that on, and then there is a huge convention center. If you ever come to CES, you need to prepare up front. It doesn't work that you just come and walk around and see what's what, because it's absolutely huge. Let's go inside and see a little bit of the technology. So one of the coolest demo is the smart house. Let's take a look at the smart house because it is my friend Avinash, my longtime friend Avinash here that is putting all this solution together. So let's talk to him and let's find out more. Avinash.
Many homes today are fragmented, have multiple ecosystems. So here we have put together the next generation autonomous home that reacts to you based on your presence, and the devices in the home not only know where you are, but they also know where each other is relative to your position. So to have this experience, I'm going to hand you off to my colleague Chris. He's going to be here shortly.
Thanks, Avinash. So my name is Chris Walzer on Avinash's team, and here I'm going to show you how, with UWB embedded in the Galaxy S23 smartphone, you can characterize and personalize the home to your own experience. So I'm going to walk in as the child phone here, and Avinash will walk in later as the adult, so we can show the house customizing to your experience. So here, let's go ahead and join me in the home. So as you can see, when you entered the home, the lights and blinds are adjusting to my presence. I've arrived in my smart home. And now, like I said, with the personalization, I like it a lot warmer in the home. So we have the set temperature go up. So the fan is turned off. And you know, there we go. Actually, the fan's turned on because it's cool enough in here. We need to warm it a bit. So Avinash will go ahead and come in now as the adult.
All right, let's see the adult.
Yes, we have the adult in the scenario. So he pays the bills. So the home will adjust to a middle temperature of 70 degrees. And in that case, you know, we're trying to conserve energy a bit, and you can't really hear it with the sound right now, but the track also changes to adjust to your scenario. Now, one thing I want to point, how is all this happening? It's not just the UWB on the phone, but it's also the fact that all these devices in here are tied together through the Matter fabric. So I want to bring you over here to talk a little bit about Matter.
All right.
So for Matter, we have two ways in which we're able to get these devices connected, either over Wi-Fi or over Thread. And here we can see an array of our devices from MPUs down to lower power MCUs, which are all using our tri-radio solution, the IW612, to get them on the Matter network. So first we have our 8M Mini, which you can see here. This is running an Android OS and has the automations and the device states of all the devices within the home. Another thing we have here that we're really excited about on our newer IMX93 MPU is the idea of this speech-to-intent model. So typically you'd have to explain to, if I use a Google Assistant saying, hey Google, it's dark in here, it won't know what to do, it doesn't understand my intent. However, with our speech-to-intent model, we can understand the intent for temperature-based commands. So I could say, hey Matter, I'm cold. And based on that, it will actually communicate back to our Matter controller the intent to adjust the temperature to a cooler degree because, you know, or a warmer degree because I'm cold, and it'll then adjust the temperature on the thermostat as well as turn off the AC.
Yeah, we can hear the silence.
Exactly, yes, yeah, a lot quieter in here. The other thing I will show is those devices I was just discussing are all connected over Thread, which is a mesh-based network using IPv6. In order to get Thread devices to the Matter network, you need something called a Thread border router. Typically, this would be in a controller-style commercial device, so a bigger unit, but we recently announced with Akara that we have this smart plug, which acts as a Thread border router. So the lights you saw are using this smart plug, as well as the door that opened and closed was using a sensor that's Thread enabled. So having this in your home allows you to start bringing in all sorts of Thread devices, like the temperature sensor. Another thing you might notice is there's no QR code on this device, so if I were to have just ordered this off Amazon, I might have to manually enter the commands into my phone app. NXP is also looking to make the onboarding process easier using our very well-known NFC communication chip. So with this, I can simply bring a smartphone, which can commission devices onto my network, tap it against this device, and here it sees that, oh, this is a Matter device. Let's use the chip tool on my phone to bring this device on the network. And if we look here right now, this device or this LED is unpaired. As soon as I begin the pairing process, it's green, and now it's on the Matter network. So simply with a tap and a few clicks, I have a new light that I can commission into my smart home. Now that we've added this device, I want to take you back to our kitchen area. So here we have Thomas with Deal Controls, who have worked with us using one of our MCUs to enable this really innovative 3-sense technology. So I'll hand it off to Thomas here.
Hello, I'm Thomas from Deal Controls, and here we have our smart cooktop. So here we are showing two different technologies. The one is the 3Sense technology developed by Dual Controls. There we have the possibility of separating three different states. We can detect the proximity of a finger, the touch and the press, and everything inside of one single button. For instance, if you want to increment the timer, you can touch by one and you're incrementing by one, and out of nature you will bring force into a button if you want to incrementing by 10 if you are in a hurry, for instance. Another feature is if you have more than one button, you can have a proximity and you can detect swipe gestures, hold gestures, tap gestures, follow me functions, which is a very nice UX at the end of the day. And it's a dead front panel, so if you switch off the LEDs, you will not see anything and you can implement wake up gestures, for instance. The second one is our person detection, which is on top here. It is running on our MCX N series microcontroller, which has an NPU inside. And as soon as I'm stepping in front of the cooktop, you can see that I'm white boxed. So all the images and everything is processed on the microcontroller itself. So the AI algorithm doesn't need to bring the privacy, the pictures, to the internet, to the cloud, where you do not want to have it. So it is increasing also the acceptance of the product, because it's increasing the privacy at the end of the day. Let's assume that you want to prepare a meal. Therefore, I'm switching on the cooktop, the burner, with a press to avoid false positives while cleaning, and it's also kind of a child protection at the end of the day. Now I want to increase the temperature, therefore I can use gloves, and I'm doing this by a contactless, very intuitive swipe gesture. The benefit of it is I do not spoil the user interface, and it's also very intuitive, so give me more, give me more, give me less. And another feature is having gloves with touch and with gestures is always an issue if you have a capacitive solution. Now the idea of the smart cooktop is, as long as there is a person in front of it, it's on. That means even if you are in a critical state, which is simulated by a hold gesture, so you can see the burners are fading, the stove is on, because maybe I need hot temperature, maybe I need some fire, depending on the use case. But when I step out, the system recognizes there is no person in front of it, and then you're gonna definitely do not want to have high temperatures or fire on your cooktop, and you could see it was switched off immediately, so it prevents your home and your beloved ones from damage. As everything inside of this room, this one is also connected to the system, to the Meta network. And thank you very much. I'm handing over to Chris again.
Awesome. So that was Thomas going through what we have in our smart kitchen. Now, I don't know about you, but after a little bit of a meal, I would like to watch some media. So what we have here, you notice how we came in earlier with the UWB, it personalized itself based on ranging technology, so peer-to-peer connection. We're using the same technology here as Haku is going to explain with our speakers, and also using a new UWB application with radar. So I'll hand it over to my colleague Haku.
Thanks, Chris. Hi, everyone. So let me introduce to you the next generation audio application here. It's really cool, not because it is wireless, but it uses wireless technology and UWB all together at the same time. So imagine if you have a soundbar and wireless surround speakers. Now, that's nothing really new, because a lot of people actually have soundbars at home nowadays, and also it comes with surround speakers with Wi-Fi enabled. Now, what's really, really cool, what we've accomplished here, is that the usage of Wi-Fi and the radar. So if you actually step in here and have your attention here at the GUI. So I just walked in front of the radar UWB here, and this basically triggers the audio switches. Right now it's playing back the regular audio, but it is going to switch into the movie mode. Now, because it's a movie time, the radar detected my presence over here with the radar, and it actually positions a person in front of the couch. Now, I'm not actually sitting on the couch right now, but imagine that there's a person here. What's really, really really cool and sets us apart from the regular current technology is that normally a lot of the soundbars actually will require you to actually calibrate the optimal position for the surround speaker positions. Now, what happens is that if you clean the house and move the surround speaker off of the optimized location, let's say you were cleaning the room, you basically moved the surround speaker, and you actually knocked off the speaker from its own location. If that happens, you have to recalibrate everything and get the microphone out and just do all these annoying processes again, which actually is very annoying and also time consuming. But what if we take advantage of the UWB's capability to measure the distance of the speakers? UWB is so smart that you can actually have each of the individual speaker aware of its own location, and not only that, able to know exactly which other speakers are in the network, and also the location of each speakers outside of its own speaker range. So I have 4 speakers there. 3 of them are actually placed in the optimal location, but 1 is red. That is intentionally knocked off the location. So if you take a look at the surround speaker here, and we can actually just move the speaker back onto the position, the UWB will basically recalculate its position, and you can actually see that GUI is moving the speaker back into its own location thanks to the UWB technology. Now it found the location. It's not just the distance though, because audio has to have not just the distance, but the angle of the position is extremely important, even though the distance may be correct. So if I tilt the speaker a little bit to the right, it can knock off the position. So UWB is so smart that it can actually even figure out the angle differences as well. Now if I tilt back the speaker again to its optimal location, voila, look at this. You can actually have the speaker actually back in its own position that it needs to be. So I hope you really enjoyed this demo over here on audio. Not only this actually is a cool technology, it is going to enhance and expand the audio features that we enjoyed today.
Thanks, Haku. So, as you saw, the entire home connected via Matter, personalizing itself to whether you're coming home or someone else, fully connected and autonomous. Thank you for joining us on this autonomous home.
Thank you, Mike.
Yeah, thanks.
All right, everyone. So that was the smart home. Really cool to see that demo. That they have amazing things there, right? And Matter, this new protocol that will make all these devices kind of work together and seamlessly integrate, is the new thing, right? Happening. It's still in the first year of life, but I think it's slowly taking over the world, and all these smart devices will work together smoothly eventually. All right, let's go more and see the health and well-being. It's another area where NXP has very good solutions, and we'll have Julia telling us more about it, and very interesting demo.
Hi, my name is Julia Tremp. I am part of the System Innovation team based in Hamburg, Germany. And we are here at CES, and I will give you a short introduction to the health and well-being demo. So what's pretty exciting here is you need to see the trend that it's we have professional medical equipment, but we also have more of the consumer equipment. It goes more and more hand in hand, so it goes a bit blurry in the lines. And we see a lot of people also using medical data as if like insulin level or heartbeat or oxygen level to improve their fitness. So using the smartwatch to really track that, improve the fitness level. So you have to have a good battery for that. So if you, for example, want to track your sleep pattern, it doesn't make sense to only kind of track it over a day, because you can also just have a bad day and a bad sleep one day. So you want to track it over time. So if you just track it like for a week or so, you don't want to charge your smartwatch every night. So this smartwatch here, or this concept, kind of lasts for a couple of weeks, so 2 or 3 weeks. We show here different building blocks that we can provide to create whatever the customer needs, to personalize it. And that is basically what you can see here on the right. So these are our companions. Where you can already see it comes in different sizes and shapes, from inhalers to hearing aids to insulin tracker, but also to smartwatches. And on the left, you see more of a concept of security and of privacy, because you don't want to have everyone to kind of read out your data. Should be the right one that you give access to it. So we have here an ECG device, so that tracks your heartbeat. How it works is that you have your health insurance card. You can just maybe get this prescribed. So the doctor says, hey, please do an ECG. You get this device prescribed, or you just buy it and just log in with my health insurance card. The device knows that that's me, basically. and I can also just register. So I just tap it behind the tablet. So it's a really easy process, very seamless. It's kind of the same thing that you use for like your bank cards or what's also inside of your passport. So it's very secure. In the end, after I register, you have kind of like an app here, and you can provision the device. Provisioning, that means that I'm basically linking this device to my ID. And I will just turn it off. And then already, you can select what kind of doctor I want to give access to it, because I don't want to have everyone reading out my data. So what the doctor would see then is a bunch of different patients, and we're also using some sort of machine learning so that this is like run over it, and it also can see if there are any like maybe problems in between, any anomalies, and then the doctor can have a closer look on that patient. And here you can see basically the heartbeat, the ECG, and yeah, that's basically a digital twin of yourself. So you can check out more information either in a virtual showroom or just on nxp.com. But please remember, everything is secured, everything is low powered, and everything is autonomous. So enjoy, look into the showroom for more information.
Thank you, Julia. Very interesting what you showed us. Another area and another topic which is really, really important these days is about electric vehicle and the way they are charging and the way they are exchanging information with the grid. And we're going to have Tristan, and he's going to talk a little bit about bi-directional communication between, of course, as I said, between the car and the grid, and how it is done safe and secure.
Hi, my name is Tristan McDaniel. I'm an applications engineer here with NXP. I'm based out of our Austin, Texas, US-based office. And today I'd like to show you a bit about our EV bidirectional charging demo deployed on NXP hardware. What this is going through and showing is, one, plug and charge. This is the ability for a user to come up to a public charging station with their EV, plug in their EV, such as what's shown here. It will go through and set up a connection via a standard called ISO 15118, and then the EV will go ahead and automatically start charging without the need for an external payment method. The EV will go through and communicate that stuff over to the charger. Second concept that we're going through and showcasing off is EV bidirectional charging. This is also known as vehicle to grid or vehicle to home, or a whole slew of other topic names. What this allows a customer to go through and do is, whenever they're coming home and plugging in their EV, they can go through and use their EV as a external battery power bank to be able to discharge energy back into the home. This could be for cases such as backup power supply in case your electricity goes out into your home, or it could be things like if you have a solar panel, you could go through and store energy gathered from that solar panel into the EV and then use it at a later time whenever you need that energy. So really it could be a user comes along, they have their EV charging at home, and then they go through and enable bidirectional charging, and all of a sudden you see electricity going from the EV back into the home. And so it's really neat what we're able to do with this stuff on NXP hardware.
Thank you, Tristan. Software-defined vehicle, while the car is transforming, is becoming something really, really cool. Let's see with Jana here an example of how an architecture of the car looks like, and she has an amazing demo.
Hello, I'm Jana Garfolo. I'm from the automotive applications team in Austin, Texas, and I'm here to show you NXP's solution for developing software-defined vehicles. NXP is announcing an SDV Foundation platform throughout this year, and what I want to show you today is our first solution for SDVs in the form of a vehicle computer. What we're really trying to do here is help automakers accelerate the complex development process for SDVs. So I'll show you some examples of how we can do that. We have a vehicle computer here operating as the central brain in the car. This is responsible for the essential functions, the things that make a car a car. How does it move? How does it behave? How does it manage energy? The brain is taking care of all of that in this environment. And this is an example architecture for how a car may be set up to control its movement and behavior. We have zone controllers controlling 4 different geographic regions, multiple apps controlled by these processors. We also have 2 smart actuators, one controlling the HVAC system and one controlling the BMS, okay? So I'm going to show you how we can use this fully scalable NXP platform to create a software-defined vehicle. So I'm going to turn on the first use case here. This is vehicle personalization. You can see here's a mock-up of the driver cockpit, and the driver's being told, hey, you have a software package available to personalize your vehicle. You could purchase this. So if the driver does the purchase, the software package comes down from the cloud into the central brain, and we get that new software ready to run. And now the vehicle is capable of changing its behavior and its personality to match the driver preferences. So I have here a key fob that represents one driver. This driver likes a very eco-friendly driving experience, okay? So when they get in the car, you can see the car's changing the cabin lighting. The exterior lighting's changed for this driver. Also, our propulsion system and our HVAC system are operating at max efficiency. So we've gone into eco driver mode, and this driver's also enjoyed an extension to their battery range, okay? Now, if I take the next driver, this driver likes a very sporty, aggressive, fun kind of feel to their car, okay? So when they get in the vehicle, you can see the wheels are spinning faster, that propulsion system is operating at max performance. We've cranked up the HVAC system to keep them cool. We've changed the cabin lighting, and we've also made the exterior lighting brighter and more aggressive, okay? So we're now in sport driver mode, and this driver has a little bit less battery range, but they don't care. They're having fun driving the way they want to, okay? All right, so next use case, we're going to talk about safe fault recovery. One of the important parts about this demo is that we are enabling essential vehicle functions, like I said before, in a car. Okay, the safety critical real-time applications that make your car move, right? We need these to be safe, we need them to be protected. Okay, so I'm going to show how we can force a fault in the software for a non-safety critical, non-required application for the car. So my HVAC system has a fault in it. It's no longer running, but you can see that the car still goes, okay, because we've isolated the software and the application inside the brain. It's not able to interfere with any of the other applications, so the car can keep going. And we can also take a software update from the cloud, fix that HVAC system, and it continues, it's now fixed, right? It's running, and the car continues to run as well. So an example of a dynamic software update that we can do to a non-safety critical application because we have a software-defined vehicle enabled by NXP's vehicle computer. So, thank you very much for listening, and for more information, please go to nxp.com. Yep, thank you.
Thank you, Jana. Here we are at our demo. I let Kurt, my partner in crime these days, to explain in more details what we've done, but fundamentally we showed how one can develop for NXP processors on a virtual development environment, and how that virtual development environment, along with all the tools, all the software, everything that is needed to program a solution fast, can reside in an Amazon machine image, in our example here, in what we call the NXP Cloud Studio. So basically, it is possible to do development from a cloud, from our cloud, from a customer cloud, from a partner cloud solution. It is possible to do development for NXP platforms. That can be done because we use a virtual development environment. That can be done before even having the processor, or it can be done, of course, for the lifetime of the car. So these software-defined vehicles will need to have a possibility to program them easily for years and years after the car is sold. There will be updates. We show here an hybrid electric vehicle and how a software update could improve the range of a car. So, but maybe I'll let Kurt say more, because because it's really his work, and a lot of this design, it's his conception.
Hello, I'm Kurt Hillier with NXP Semiconductors. I'm here with you at CES 2024. We've had an excellent show, lots of customers, visitors, partners, dialogue. It's really been excellent. I'm going to show you a little bit about an exciting new demo that we put together. It's called the NXP Cloud Studio. I'll tell you a little bit about what it does and why do you care. So let's go ahead and look at high level this demo and its purpose in life. One of the things I'm going to tell a story here that I'm sure all of you have experienced is that you have hardware teams and you have software teams and you have a schedule. Well, what happens? Everybody gets ambitious, it's all going to work. Next thing you know, the hardware's delayed, but the end goal doesn't change. What happens? Software teams start to get crunched. Oh my gosh, you're working weekends. Oh, you're working nights. Oh, you're the bad guy. So what we want to do is make sure that our beloved software customers are not the bad guys anymore. So what we want to do is start you early. The reason we can start you early is we invest in virtual models with Synopsys and ASTC. What that is, it's a software copy of a chip. You don't have to wait on your board developers. It can run on your PC or it can run in the cloud, and you can start writing drivers, test cases, you get your tool chains up and running, get rid of dependency problems, all those things you could start early in the project such that when hardware finally hits your desk, you're really ready to go. You're not the bad guys anymore. So start early. We can also provide the ability to scale your teams. One of the annoying things that we have as an applications developer is tool chains. I got to install this tool chain. It's the wrong version. I got the wrong path. Oh, I don't have this license. One thing we can do for you, pre-bundle all that. You want to start writing code. You don't want to go find the license. You don't want to, oh, this, I don't have the right path. Oh, I don't have, so that's the other thing we want to do is make that easier for you as a software developer. Once we pre-build those environments, they're running as like a digital copy in the cloud. You have new team members come on board, 20, 30, 50, 100 developers. You can all access the shared system. You get your own instance. It's pre-installed and you're ready to go. So this is all about allowing you to hit your timelines. That speed, that time to market, really getting rid of all the headaches is what we want to try to do for you. And then finally, once you have that platform, it's up and running, it's got quality, you have regression tests built around it, you can use it for the life of the vehicle. If you build a high quality model, you've got all the tooling that you need. If you have a bug in the field, you can try to replicate it in the virtual environment. See if it matches the hardware environment. Then you can isolate bugs. You can see what's happening. You look at stack traces. You have all this power and capability for the long haul. So I'm not going into great detail today. We're going to talk a little bit about ecosystems. We have a lot of very valuable partners, Amazon Web Services for cloud infrastructure. We build on AWS. We use Synopsys for virtual hardware, virtual prototypes. The MathWorks for model-based design development. We use the model-based design toolbox from NXP. We compute on ARM, M7s, A-cores, A53s, R52s, all possible through the tooling that we have. And then we have Airbiquity as our over-the-air update partner, and ICAS for signal gathering and signal processing. We like to talk about the data lifecycle, the code lifecycle, providing updates to the vehicle, gathering data, analyzing it for the long term, and then having these efficient DevOps pipelines built for our customers. So we really see a lot of value in what we're doing, and we appreciate all the work that our software teams are doing to put this in place and make it usable for our customers. We'll wrap up here. This is the instance that our team in Bucharest built for us, and we have a cloud instance, runs in AWS. We've got an Amazon machine image that we can fire up whenever we want to. And then finally, we have our Synopsys VDK, so I can write code wherever I am in the world. Las Vegas, my house, I'm on vacation, maybe I have to check in and look at a bug. I can really access the system from wherever I am in the world, It's got a lot of value and a lot of capability. So anyway, that wraps it up. Thank you for your time. Good time in Las Vegas. Thank you to Daniel Skirtu for all the time he spent at this booth when I was off eating lunch or talking to other people. We've really had a great week, so thank you all.
Thank you, Kurt. All right, so that kind of concludes the walkthrough here. I'm sorry I could not show you all the work, and that this would become an even longer video. It is probably already way longer than it should have been, right? maybe just before finishing, let's take a look and see the strip. You can't be in Vegas and not see a little bit of the strip, right? So we'll do for the ending a little bit of that. And I know we said we're gonna go and see the strip, but we're gonna do that tonight. Strip is always nice on the dark, right? To be able to enjoy the neon lights and all these things. So we still have a couple of hours. I still have a couple of hours, and I was planning to actually go and see a little bit of the CES to see what the others do. There is another way to travel around. There is this Tesla Hyperloop kind of thing, which seems to be incredibly cool. So we will go and gonna take a Tesla, drive under Las Vegas through a tunnel, and enjoy that. So let's do that, because everybody said that is a cool experience to travel between the convention centers. And then it seems to be all about LEDs, a lot of LEDs, a lot of, you know, transparent panels and all these things. So let's go on and see that. And there are drones. There is a game of drones. Rusvan has seen a game of drones where the drones are kind of protecting a circle, and you're not allowed to go into the circle. So is this? It looks like these Aztec games when you need to put the ball through a circle. Only it's with drones. I mean, it's 2024. It's normal. And then before we go and see the strip, I think we have to go and see through some of the hotels. This omnipresent gambling. We need to take a look at that, right? This is Vegas, and we have to see inside. And then in the evening we'll do the strip. Let's see how that works. Thank you, Michael. Great music. I wanted to let you feel the real experience. This is what the driver was listening. This is how it felt inside the tunnel. This is the middle station. So basically with these Tesla cars, you can travel between 2 points in the convention center. This is a very quick ride. As you could see, it's almost real time. It's 2.7 kilometers, 1.6 miles, and it connects to convention center stations. And this is the underground station. This is how it felt, this is how it looks. They will continue to extend this, and yeah, you've been driving under Las Vegas.
Sorry.
As you can see, with software-defined vehicle, even the appearance of the car can change.
Able to steer. What it does is it aligns in one direction, allowing for stable driving, even in very narrow situations, as well as reducing shaking, so no worrying about spilling your coffee on the way to work. Now I'd like you to observe our pivot turn. By steering only the rear wheels and keeping the front fixed, you're able to turn like a compass, making difficult parking situations more convenient. and no more worrying about minor collisions while trying to park in tight spaces. Together, let's watch this diagonal drive demonstration and pivot turn right here for you. Notice those front and rear wheels aligning in the same direction, allowing you to seamlessly navigate to that front edge of the display. And then, of course, our pivot turn. Right there on a pivot, single pivot point, the back wheels move, the front wheels stay stationary, and ever so slightly those front wheels will turn, coincide with that amazing movement. It's incredible to see Mobian's e-corner system in action. Have a quick round of applause for Mobian and that riding demonstration. Thank you.
The world is going more digital. It becomes more incumbent upon us as technologists to be engaged in the policy discussions, in the regulatory frameworks, so that we help close that gap, that regulation is in place to support this ever-hastening pace of technology and the implications on society.
Pat Gelsinger, CEO of Intel, had a very interesting keynote at the Venetian. You can find it on YouTube.
We do think that there's going to be these cloud-assisted environments, where people will do foundational models in the cloud, where we need these big, huge environments to create these foundational models.
And as a historical fact, Pat is also one of the key members who defined in the early 80s 386 processor.
Increasingly, and I believe a lot of, the
Let me give you a crash course on the strip. I'm here at the Venetians. Looks nice, full of light. And let me just tell you quickly how it is. Now it's evening and we finally do the strip. So inside it looks amazing, right? They have all kind of streets. Behind me is the gondola, is where you take the gondola. They replicate Venice. I have some I don't know what is this, kind of Chinese New Year preparation or something. It's really nice inside. You have all kind of streets with shops and these, replicas of something. They have a replica of Paris. They have you can hear the singing from the gondola. A lot of gambling. So this is everywhere, right? In every shape and format, there is gambling involved, right? And you get used to it. After a while, it's like, okay. I saw it where you pick up your luggage from the airport. That was a surprise. It's like you pick up your luggage and you can, play a bit. And also, of course, at the gate. So just before leaving Las Vegas, you can still place a bet. All right, I'll show you some more interiors. There is a lot of paint. There are a lot of paintings. There is there are all kind of things.
Volare, oh, cantare, oh, let's fly way up to the clouds, away from the maddening crowds. We can sing in the glow of a star that I know of, where lovers enjoy peace of mind. Let us leave the confusion and all disillusion behind. Just like birds of a feather, a rainbow together we'll find.
So yeah, there's no place like Vegas, okay? Maybe it's kitsch, but it's not any kitsch. It's grandiose kitsch. See this. Dodge Palace is here.
Volare, oh, e cantare, oh, nel blu dipinto di blu, e che dici di stare lassù? E volavo, Venice, punalte del sole con coro più su, mentre molto pian piano sparivo lontane laggiù. Una musica dolce suonare soltanto per me. Volare, oh, oh, e cantare, oh, oh.
Few people know that actually the airport is quite close. It's almost kind of arguably downtown. By American distances, it's quite downtown. The strip arguably starts at the sign and ends up at Sahara, or the other way around, as you want to see it. Then there's a pyramid. I don't know what exactly it means. We didn't have time to go see it through, but it's amazing. It's big. And then you have the MGM and the New York, big agglomeration of the Manhattan building. At MGM, it's David Copperfield. So there we went and saw David Copperfield. I mean, I grew up in the 90s when he was amazing. It was amazing. It still is amazing. So having a chance to see him was cool. So Bellagio is the fountains, Little Paris, and all these things are there grouped together. And here is the Venetian, a big, nice place. You know, I don't know yet what to make out of it, but it really looks interesting. And then you can go on more. It's Circus, and then it's Fontainebleau, this big one, and then it's Sahara, where we actually stayed. So for a week we stayed at the Sahara, and from there we took the monorail and drove. A lot of LEDs, as you can see. You saw at CES a lot of LEDs and all kind of screens, and here there is also the ball, right? The sphere. The sphere is amazing. Yeah, it's visible from everywhere, and even during the daylight, it's cool. So this is in a nutshell the strip. I'll let you a few images to enjoy it, and thank you all for watching this. Yeah, and being here in Vegas, I hope you'll have a chance to come around, and why not at the CES next year, or who knows. One more thing, if you made it up so far, I have one last thing. You know, you cannot come to Vegas and not do the Hoover Dam. Amazing engineering feat. We were able to walk inside to see it.
Canyon walls here are much closer together, so they could build it taller with less concrete. Also, it has to do with the makeup of the rock in the actual canyon wall. You saw those in those tunnels that you were walking through when you came through. That is mostly an andesite breccia. The other location was mostly granite, so it was a lot harder to drill and blast out. So those are those three main reasons that they chose Black Canyon over Boulder Canyon.
And one of the other systems it powers is that big green thing with the American flag hanging from it. That is a P&H bridge crane. There's a second crane even further down the length of the powerhouse, and then two more in the Arizona wing. Now, each crane has a lifting capacity of 300 tons, which, to give you an idea of just how much that is, the Statue of Liberty in New York Harbor, she weighs about 225 tons. That crane could easily lift Lady Liberty, which I think that's pretty neat. But it's not what we use them for. We use these cranes for maintenance, as our rotors can weigh up to 600 tons. It takes both of these cranes just to lift one rotor. And in fact, that's what the circular object below you off the balcony is. That there is the Nevada 3 rotor. It's currently being rebuilt after some maintenance was done to it.
If you ever have the chance, come along. Plus we end up on a sunny note, finally a little bit of sun. But if this is how it is in January, I don't want to imagine how summers are here. I'll let you enjoy this. Thank you all for watching. Been a great time.
Sitting on the fence, that's a dangerous course. You could even catch a bullet from the peacekeeping force. Even
there are like a lot of cool things one can do in Vegas. One of them is this Red Rock. It's like half an hour from Vegas. If you have a time and a little bit of space in your calendar, this is something you should try. I'll show you how small the people are to get an idea of how big these stones are and what can be done. Someone is doing some wall climbing there, huh? I guess it should be a very good place for that. Yeah, this is just half an hour drive from Las Vegas, from downtown, so very, very quick. And it's yeah, as you can see, it's impressive. It's still cold. This sun might give you the feeling that it's warm, but it's not. It's still chilly. And the sun is nice, yeah. And then there are these rocks, and there is a trail. One can do a walk. And anyway, the scenery is impressive. Check this out. The best selfie I have ever done. That's me and Razvan there. This is me. That's Razvan. Most beautiful one. This should be our Instagram. I don't have an Instagram, but anyway, if I'll ever make it, this is the photo. Two insignificant dots, amazed by this beauty.
Big bad Leroy Brown, he got no common sense. He got no brains, but he sure got a lot of style. Can't stand no more in this here jail. I gotta raise myself with this sentence. Gotta get out the heat, step into the shade. Gotta get me that dead or alive. Then she met him down at the station, put a shotgun to his head, and unless I be mistaken, this is what she said. Big bad little brown. I'm gonna get that cutie pie.
If you have a few days or a little bit of time, there are a lot of things you can do living from Vegas. Things which are like, in a half an hour, maximum 2 hours of driving from Vegas. It's not gambling, but it's still, I think it touches the same dopamine path. So you might feel as good as gambling. I don't know. But there are a lot of beautiful nature walks and you can go and try. So I'll show you some of them where we've been. I had some time to walk around, and it is amazing. If you ever come to Vegas and you can plan and you have to see. I have behind me a canyon in the Death Valley. The colors are amazing. It looks surreal. And I invite you to follow me.
Plus bleu que le bleu de tes yeux, je ne vois rien de mieux, même le bleu des cieux.
Plus blanc que tes cheveux dorés, ne peut s'imaginer, même le blond des blés.
Plus pur que ton souffle si doux, le vent même au mois d'août ne peut être plus doux. Plus fort que mon amour pour toi, la mer, même en furie, ne s'en approche pas.
Plus bleu que le bleu de tes yeux, je ne vois rien de mieux, même le bleu des cieux. Si un jour tu devais t'en aller et me quitter,
mon destin changerait tout à coup, du tout au tout. Plus gris que le gris de ma vie, rien ne serait plus gris, pas même un ciel de pluie.
plus noir que le noir de mon cœur, la terre en profondeur n'aurait pas sa noirceur.
Plus vide que mes jours sans toi,
aucun gouffre sans fond ne s'en approchera.
plus long que mon chagrin d'amour,
Même l'éternité près de lui serait courte.
plus gris que le gris de ma vie, rien ne serait plus gris, pas même un ciel de pluie.
On a tort de penser, je sais bien, au lendemain.
À quoi bon se compliquer la vie, puisqu'aujourd'hui, plus bleu que le bleu de tes yeux, je ne vois rien de mieux, même le bleu des cieux.
Plus blanc que tes cheveux dorés ne peut s'imaginer, même le blond des blés. Plus pur que ton souffle si doux, le vent même au mois d'août ne peut être plus doux.
Plus fort que mon amour pour toi,
La mer même en furie ne s'en approche pas.
plus bleu
Que le bleu de tes yeux,
je ne vois que les rêves
que m'apporte tes yeux.
I can see what you're looking to find in a smile on my face. In my peace of mind, in my state of grace, I send what I can to the man from the minister race. He's a part of heaven's plan, and
Look at this place, is amazing. I know I said goodbye already a couple of times. But from Hoover Dam we drove by car like I don't know, 1 hour and a half. I guess where we are is like Grand West Canyon. I'll put the link. And we drove like for I think it's 2 hours from Vegas. And the view is amazing. It took my breath away. So I thought, even if this video starts to look like a soap opera, you know, endless, I could not resist now to put it. I know it's a video about technology, but you know, we are people. We don't just do programming, you know, we also live our lives. If you ever come to Vegas, put this on your roadmap, because on your calendar, right? Because it's a great place. It's not far from Vegas. It's a half-a-day trip, I think. You might need a car for that. And it's absolutely amazing. The view, the way things look is like unbelievable, you know. Literally takes my breath away. This is it, I promise. It's getting dark here. Going home. So no more videos, no more postscriptum or anything like that. Take care, stay healthy. I'll let you enjoy these last images, and see you next time. And by the way, if you made it so far, you're a very, very special person. It means your attention span is way, way, way above average. I guess by now you can subscribe to my channel if you really made it so far. As you can see, yeah, I make very long videos. Take care, stay healthy, and enjoy it. I hope you enjoyed it.